Today's lesson is going to be using a graph and determining parallel and perpendicular slopes and lines that would be associated with them. Uh, Now, a couple of review topics. So yesterday we went through given points, being able to calculate using the formula, using your x2, your x1, your y2, and your y1, knowing that y is always going in the numerator, x is going in the denominator, and calculating slope that way. Now, what you didn't see is my blooper reel, so that's why all these things are already written here because I got partway through and then I made a mistake. So you don't get to see the blooper reel. With slope, it is a rise over a run, and the key to remember about rise is that's your vertical change. How much is something going up or how much is it something going down? Run is the horizontal change. How much is something going left or how much is something going right? Remembering that every time you move in an up direction, we are talking about positive numbers. If we move in the down direction, we're talking negative numbers. If we move in the right direction, it's positive. If it's left, it's negative. So over here, if I'm trying to find the slope of the line given, because when I look at the directions, it wants me to create a second point to create a line parallel to the given line. So here's the line I'm given. I want to be able to make a parallel line passing through this point. So I have to create the second point to know, well, is it going to be here? Is that going to make it parallel? Is it here? Is that going to make it parallel? And although you might be tempted to eyeball it, we want to make sure we find it exact. Now, there is more than one answer because we know that a line is made up of an infinite number of points. So you're trying to identify at least one point that's correct. So when you are moving from coordinates, points on a line that's already given to you, you have the choice. Remembering that we're rising and we're running, we can either start at this top point and we can run down and then right, or we can start at the bottom point and run up and then left. Either direction, you know that the vertical changes 2 and the horizontal changes 4. So this box around those points, the segment connecting the diagonal is the line we're talking about. And so I see the vertical change and the horizontal change. Remembering that slope is always rise over run, I need the vertical change on top and the horizontal change on bottom. So my vertical change is 2, my horizontal change is 4, but I want to check my signs because I know this is going downhill, so my answer should be negative. So I need a negative sign somewhere. If you're using this top path, you're going up, which is positive, and left, which is negative, which would make it 2 over negative 4. If you are taking this other path, you would be going down 2, right 4, which would make it negative 2 over 4. Either of those work, but you do want to simplify that slope to say that slope is actually negative 2 over 4 is going to be a slope of negative 1/2. And just as a refresher for you, if you say, I'm terrible with fractions, Miss Rogers, I understand if you are. That's why I give you the opportunity to use a calculator. You can use the app on your Chromebook. And if I have 2 divided by negative 4, and I hit math, enter, enter, it will tell me that the slope is negative 1/2. If I do negative 2 divided by 4, math, enter, enter, I will also get negative 1/2. So you see that they both simplify to be the same thing. And what that's telling me is that to go from point to point, I could have done a shortcut and went down 1, right 2, down 1, right 2, down 1, right 2, and that would be the process of that entire line. So now that I know that, if I want it to be parallel, parallel has the same slope. So it has to have the same slope. So that same movement has to happen when I go from this dot. So I have to go down 1, right 2, down 2, right 4, down 1, right 2. I can go up here, down 1, right 2. I could have went up 2, back 4. It would have taken me off the graph. So if I go up 1, back 2. So whether you do the combination of 2 and 4, or whether you do the combination of 1 and 2, you will hit every point along this line. So if I started at this point, went down 2, right 4, down 2, right 4, I'd hit these 2 points. If you simplify it and go down 1, right 2, down 1, right 2, I'll hit every point. So all of those points are acceptable. All of them will make it there. So I'm going to use my ruler to now draw the line, passing through all of those points. So any one of those coordinates would have been a correct answer. Now, the one beside it. Parallel, I find students succeed wonderfully at. But when I throw perpendicular, it starts to get a little more confusing to others. So let's go through this one a little slower. So the idea with perpendicular is I still have to calculate the slope of the line that I have. So I either am going to rise, run, or rise, run, one of those two directions. I'm just going to draw one this time, and I'm going to start at this lower dot and work my way up to the upper point. And so if I am using, let me get a blue highlighter here this time. If I'm starting at this lower point and I'm going to rise and run, you will find that my rise, 1, 2, 3, 4. My run is 2. Everything is positive because I'm moving up and I'm moving right. My line is positive, so my slope is going to be a 4 over a 2. If you had went the other direction, you would have had a negative 4 over a negative 2, which a negative divided by a negative would turn me positive. I do want to simplify this slope. Simplifying it will just help assure you that you'll be able to keep it on the graph. Sometimes if the numbers stay large, it might run off the graph. So when I simplify 4 divided by 2, that gives me a slope of 2. But because I want to think in terms of rise and run, I'm going to leave it as a 2 over a 1. So that's my slope now. But I need the slope perpendicular. So remembering from yesterday, or when you did the last lesson, perpendicular slopes always have opposite reciprocals, which means I need to flip and change the sign. Flipping takes care of it being a reciprocal, changing the sign takes care of it being opposite. So if my current slope is 2 over 1, when I flip it and change the sign, I need to be negative a half. Remembering that negative can either go with the top or the bottom. So I can call it negative 1 over 2, or I can call it 1 over negative 2. I only give you all 3 options because now we're going to start at this point and think about that slope. So over here, when we had negative a half, we went down 1, right 2, down 1, right 2. Well, we're going to do the same thing over here. Just so happens that the slope perpendicular of this line is going to be the same as the slope parallel to that one. So we're looking for this slope to be coming over here. And if I put my pen in that direction and drag it, you'll see that it will create that right angle when I draw it. So now let's just actually put it on the graph. So I tend to put my negative with the numerator, so I usually go down 1, right 2. But say you need to go the other direction because I've run out of graph. I can now flip it, and this means I'm going to rise 1, but I'm going to run in a negative 2 direction. So rising 1 is going to go up 1, but in the negative 2 direction, I'm going to go left 2. So I'm going to go up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. And just as I mentioned over here, you can use the 2's and the 4 ideas. It would end up being a 2 over a negative 4 or a negative 2 over a positive 4. It would just skip over some of the dots. When you simplify it, you hit every dot. And so now, if I take my ruler and draw a line through all of my dots, my line hopefully will be perpendicular. Now, you might say, but if I stick that in there, it might not fit absolutely 100% perfect. Did I do something wrong? Most likely not. It's probably because when I copied this paper, those might not be perfect squares. They might be more rectangular, and so it might not look as perfect perpendicular wise. So now there are 2 at the bottom. The one on the left asks you to do a parallel to that line shown. The one on the right asks you to do perpendicular to that line shown. So pause the video and try each one of those. Okay, I hope that you've paused and you've taken a moment to try these two questions. Now let's check your answer. So let's do the parallel one first. So remember, the parallel should run side by side, not cross and not intersect. So when I did my slope of the actual original given line, I went down and right. So I went down 6, right 2. When I do negative 6 over 2 and reduce that, it becomes negative 3 over 1. So that would be my slope. So now that my slope is that, I now have to remember that my slope parallel is going to have that exact same slope. So it will also be a negative 3 over 1. You can leave it negative 6 over 2, but I worry that you would run off the graph. So when I come to the point that we started with, and I go down 3, right 1, I get this coordinate here at 0, negative 4. If I tried to go again, I would run out of graph. So I'm going to reverse it and think about, well, what if I go up 3 and down 1, moving the negative to the bottom? Up 3, back 1, not down 1. Up 3, back 1, up 3, back 1. That's going to give me my other two coordinates that are up there. So those 3 dots would all be acceptable answers, and I just drew the line through to give you the approximation so that you can see the 2 lines run parallel. Now with the perpendicular one, the blue indicates me finding my slope, so I did a rise and a run. Rise of 1, run of 4 gives me a slope of 1/4. Cannot simplify that any further, so the slope perpendicular, I'm going to flip and change its sign. Opposite reciprocal. Opposite being negative, reciprocal being 4 over 1. You could simplify this to negative 4, but again, I want to keep a rise over a run. So I go back to my original dot that was plotted, and I go down 4, right 1. Down 4, right 1. I wanted to go backwards, so I can go up 4, back 1. And that's going to create 3 dots along there that when I connect them give me my line. And again, my hope is that I can see if it's approximately perpendicular. Again, the lines aren't necessarily hitting the dots perfect. My squares might not be perfectly square, so that might be why it might be a shade off of each other. So now, if I flip to the back of this page, you're going to see 2 situations where I ask you which ones are parallel and which is perpendicular to line M. So in these situations, I want to count slopes. So I have line G, line H, line J, and line K. So what I would do is I would find the slope of each one. The slope of line G. If I do the rise and the run, up 1 over 4. My slope is 1/4 for line G. If I do my slope of H, I'm going to rise 1, run 3. So my slope is 1/3. If I do my J, my rise and my run, so my slope here is going to be 1/4. And when I do K, for my slope, I'm going to rise 1, run 5. So what I'm looking for when I have parallel lines is I'm looking for the same or the identical slopes. So when I compare each one of these, I have 1/4, 1/3, 1/4, and 1/5. The ones that are parallel to one another would be the 2 1/4. So that would be line G and line H. So G and H would be parallel to each other. Over here, now we want perpendicular. So this time you have 5 lines because you have M, which M is the original starting line that we want to compare everything to. So we're looking for which ones make that perpendicular or that right angle in here. And you might say, well, can I just take this and estimate it? Estimating will get you so far, but it might not be a perfect estimation. If I had to estimate right now, I would say the one that looks closest is B or possibly C, but maybe I'm a little off in my counting. So let's just double check. So let's start with line M. The 2 coordinates are the 2 points that are labeled on M are here at 0, -1 and at 2, -2. So when I calculate those slopes, I'm thinking rise, run. My rise is actually a fall, so that's going down 1, right 2. So my slope right now is down 1, right 2. If I remember that perpendicular needs me to have opposite reciprocals, the slope perpendicular is going to flip and change that sign. So that should be a 2 over a 1 positive. So I'm looking for A, B, C, and D, which one does a 2 over a 1 positive. So if I test them all, find the slope of A, that means I'm going to go rise 3, run 1. So it has a slope of 3 over 1. Not what I'm looking for. When I do B, rise 2, run 1, that is what I'm looking for. But I just want to show you the other two to be sure. C is going to rise 3, run 2. And D is going to rise 1, 2, 3, 4, 5, 6, 7, and run 3. Didn't draw that one very well for you there. So I have a lot of little lines there. This is one reason I always suggest highlighters, because it definitely helps when you're looking at these pictures to be able to draw on them. And if I look, the one that has the opposite reciprocal of what I started with is B. So my guesstimate was correct. The one perpendicular was line B. So please go see Schoology and look for your assignment for today.